Hello guys, welcome back to the channel. In today's video, we will clear up the air about misunderstood concepts in software development. In today's video, we will go over terms that are currently being used interchangeably, with one often being mistaken for the other. There is a fine line between these terms, even if they are used interchangeably, and you should know that no matter how close or related these terms are, there is a clear distinction between all of them, and the aim with today's video is to show you that distinction. If you think that's a great idea, then absolutely smash the like button. Ensure you subscribe to the channel and turn on the bell notification so you don't miss any of our videos as they drop. Ensure to leave your thoughts on the video via the comment section. I would love to read each and every one of your comments. So let's get straight into it, starting with parameters versus arguments. There is a clear distinction between what a parameter is and what an argument is. So let's start with what a parameter is. A parameter is a variable that is defined in a function's declaration. It is a placeholder that specifies what kind of data the function expects to receive. Think of it as the empty slot in a form that needs to be filled. Parameters only exist in a function definition, while an argument is the actual value that is passed to a function when it is called. It is the real data that fills the parameter's placeholder. Think of it as the actual information you write into the form's field. Encapsulation versus abstraction. These are two fundamental principles of object-oriented programming that work together but serve different purposes. Encapsulation is the process of bundling properties and functions that operate on data within a single object/class, while restricting direct access to some of the object's internal states. While abstraction is the process of hiding complex implementation details and showing only the essential features of an object. It simplifies complexity by modeling classes appropriate to the problem. Think of it as a car's dashboard. You don't need to know how the engine works internally. You just use the steering wheel, the pedal, and the buttons to drive that car. Imperative versus declarative programming. The difference between declarative and imperative programming is perhaps the most fundamental philosophical divide in software engineering. It is about how you express your intentions to the computer. Imperative programming focuses on step-by-step instructions that change program state. You explicitly describe how to achieve a result through statements that modify memory, variables, and data structures. It focuses on control flow using loops, conditionals, and this is very common in languages like C, C++, Java, and Python. While declarative programming focuses on what the result of a program should be, not how to compute it. You describe the logic of computation without describing its control flow, and this is common in languages like SQL, HTML. Let's look at framework versus library. Oh, I'm really excited about this one because this is one of the hottest topics in software development. The difference between a library and a framework is about who controls the flow of execution in your application. A library is a collection of reusable functions, classes, or modules that you call when you need them. They don't alter your application structure, and you remain in control of your application's flow and structure. So examples of libraries include Lodash, Axios, DateFNS, and there are loads of other libraries I cannot just add for time's sake. Why? A framework provides a structure and flow for your application. It calls your code at specific points while you fill in the blank spaces. And examples of some frameworks are Nest.js, Express.js, and Angular. The distinction between them can be thought about like when building a house. So think about it like this. With a library, you're given a toolbox, let's say some hammer, some nails, a saw. You decide when to use each tool. While with a framework, you're given a prefabricated house frame. You fill in the walls, the rooms, and the structure is already decided for you. So with that, I want to ask a question. Is React a framework or a library? Let's look at delegation versus composition. Delegation and composition are two fundamental object-oriented patterns for code reuse and relationship building, but they approach it from different angles. Composition is when an object is made up of other objects. The containing object owns the contained object. Delegation is when an object passes responsibility to a task to another object. Instead of implementing functionality itself for that task, it asks another object to handle that task. Let's look at errors versus exceptions. Errors and exceptions are two different kinds of of something went wrong in programming, but they represent two fundamentally different problems. An error represents a serious problem that a reasonable application should not try to catch. Errors indicate problems that are outside the control of the program, like system failures or virtual machine issues. Examples of errors are reference error, which is encountered when trying to use a variable that does not exist, or a syntax error, which is encountered whenever there's an invalid code. An exception represents an exceptional condition that a program should catch and handle. Exceptions are part of a normal program flow and represents predictable problems that can be recovered from. Let's look at compilation versus transpilation. The difference between compilation and transpilation is about what kind of code you're converting to. Compilation is the process of translating source code written in a programming language into machine code, bytecode, or another low-level language that can be executed by a computer. Transpilation, which is source-to-source compilation, is the process of translating source code from one high-level language to another high-level language at the same abstraction level. Concurrency versus parallelism. The difference between concurrency and parallelism is one of the most subtle but important distinctions in computing. Concurrency is about managing multiple tasks that start, run, and complete in overlapping time periods. It is about structure, how you design your program to handle multiple things. While parallelism is about executing multiple tasks simultaneously using multiple processing units. It is about execution, actually doing multiple things at the same time. Parallelism requires multiple CPU cores and focus is on performance and throughput. Machine learning versus artificial intelligence. Artificial intelligence is the broad field of creating machines and systems that can perform tasks requiring human-like intelligence. Artificial intelligence includes everything from simple rule-based systems to complex neural networks that mimic the human brain. Machine learning is a subset of AI focused on building systems that can learn from data without being explicitly programmed. Instead of writing rules, we show examples and let the machine discover patterns. It is a data-driven approach. It learns from examples, which is usually called training data. So that's going to be it for this video, guys. I hope you found it useful and interesting. Absolutely smash the like button. Ensure you subscribe to the channel and turn on the bell notification so you don't miss any of our videos as they drop. And I will see you in the next one.